Hello, welcome to this video 2-2, part C on adding and subtracting rational expressions. In this video, we're going to cover example 2 and example 3, and we're also going to look at some practice problems. So if you're missing the foundational piece, the step-by-step process for how to add and subtract rational expressions, as well as excluded values, you'll want to go back to the previous videos and view those. So without further ado, we're going to jump right in and look at these examples. Here we have two rational expressions, and we're asked to subtract them, and as well as state any excluded values. So the first thing that you want to do with these rational expressions is factor them. So I have a difference of squares in the denominator, and that's our first rational expression. Now I want to subtract x minus 2 over, and I'm going to go ahead and factor out a GCF of an x, leaving behind a 2x minus 3. Okay, and it's important to go ahead and factor right away, right? So now we can find the LCD. So this was step 1. So LCD, what is our LCD? Well, I know that I have a 2x minus 3 in common, so that's part of my LCD. And then additionally, left off a parenthesis here. Additionally, we have a 2x plus 3 as well as an x. Okay, so x and then 2x plus 3. Okay, so there's our LCD. Step 2, what we're going to go ahead and do, we are going to state our excluded values. So I just set each piece equal to 0. X equals 0, 2x minus 3 equals 0, and 2x plus 3 equal to 0, right? Because that's our denominator cannot equal to 0. Otherwise, we get vertical asymptotes or maybe a hole in some cases, and they can't be part of our domain. So we'll go ahead and solve these. Now notice, again, when we have a factor of x equals 0, you don't have to do any solving. That's already done for us. So I'll add 3 to both sides, divide by 2, so x equals 3/2, and then over here we'll subtract 3, divide by 2, and we have our excluded values. X cannot equal 0, and I'll add this in. Cannot equal 0, cannot equal 1.5, and cannot equal negative 1.5, okay? So next, we're going to go ahead. This is step 3. We're going to multiply in our factors, okay? So I'll just put an equal sign over here. This is step 3. I have my factor x plus 4 over 2x minus 3 times 2x plus 3. And I'm going to multiply in the missing factor, which is x. So multiply in x over x. Okay, minus, so minus x minus 2 over x times 2x minus 3. Okay, and I'm missing 2x plus 3. Okay, so now what we get, this is equal to, so we have x squared plus 4x, right? All I did was just distribute. Okay, and in the denominator, I have x times 2x minus 3 times 2x plus 3. Okay, minus, and I have, I'm going to go ahead and FOIL this. I'm going to distribute these terms here. Okay, so 2x squared plus 3x minus 4x minus 6. Okay, and I'm going to put this in parentheses, and I'll let you know why I'm doing that in a moment. X minus 3 and 2x plus 3. Okay, so I've introduced my factor, and I have multiplied those out. Okay, so there's step 3. And then lastly, step 4, I'll put this in red here. we're going to go ahead and add or subtract. Now, I have this negative, right, which is going to change every single term, okay? And notice, right, these are like terms, so we will combine those, okay? So we have x squared plus 4x minus 2x squared. Positive 3x and negative 4x make a negative x, but with that negative, it becomes a positive x. And then we have a positive 6. All over, whew. My hand went shaky there. Okay, over x times 2x minus 3 times 2x plus 3. Okay, and our last step, we're gonna go ahead and simplify this. I have a negative x squared in my numerator. 4 x's and 1x gives us 5 x's plus 6 over x times 2x plus 3 times 2x minus 3. No reason I switched those factors in the denominator. I just did. Okay, and then we state our excluded values. X cannot equal negative 3 over 2, comma 0, comma 3/2. Okay, if you like writing your values in decimals, feel free. I'm okay with that. If you like doing it in fractions, feel free. I'm okay with that. Okay, just if I just ask if you're in Miss Page's class, just defer to whatever she wants. Okay, whatever she says. All right, so that's example 2. Okay, here is example 3. Go ahead and write this one down. This one has a different look. So when we factor this, we have 2x minus 4, and in our denominator, I'm going to factor out an x minus 5, plus x plus 6, over x squared. Now, I want you to think about x squared in expanded form instead of exponential form. This is x times x. Now, what's the purpose of this? Well, the purpose is when you find your lowest common denominator, I'm going to ask you what's the same, and you're going to say, oh, well, they have an x in common. Yes, they have one x in common, okay, but you have to bring along that other x. So I have to bring along this x, okay, that's left out, and then I have to bring along x minus 5. Okay, so what is your LCD? Well, it's x squared times x minus 5. Easy enough. Okay, step 2, excluded values. I'm just going to set each of these equal to 0. X equals 0, x equals 0, x minus 5 equals 0, and I'm going to solve, okay, which gives us x is equal to 5, x is equal to 0, and I have double those, so you only count one, right? X 0, you're not coming along, okay? Sorry. All right, so those are your excluded values, and now we want to go ahead and introduce our missing factors into our expressions. Okay, I want to be able to add these expressions with a common denominator. Okay, so x times x minus 5. So notice how our first expression, right, I'm missing an x. So I have to multiply by an x and another x, okay? This expression over here, I'm missing the x squared, so I multiply by, what did I say? I have the x squared, I'm missing the x minus 5, so I'm going to go ahead and introduce x minus 5. Okay, so this gives us 2x squared minus 4x over our denominator, x squared times x minus 5 plus, and over here we get x squared. That's a plus 6 and a negative 5. That's going to be a positive x minus 30, okay, over x squared times x minus 5. If you're confused about how I got this x here, I just FOIL this out. Distribute, right? You're going to get your plus 6x minus 5x, okay, and you get your term there. All right, so we're good to go. We're going to go ahead and add these. Notice with the plus sign, right, I don't have to distribute that negative. So we don't have to worry about the signs changing and anything weird happening. So I'm just going to add these. 2x squared plus an x squared. A negative 4x and a positive x gives us negative 3x. And I have negative 30 all over our common denominator, x squared times x minus 5. Now, what's your excluded values? X cannot equal 0, and it cannot equal 5. All right, there you go. That's example 2. Okay, I'm gonna just close this video out with your practice examples. So here is the first practice example. Please hit pause right now. Pause it, do it, pause it. Okay, and then come back and I'll post the answers. So pause it. If you have questions, write it down. And then if you need to take a peek, take a peek. Okay, hopefully you paused it. Here are the solutions. Okay, you can pause the video and look at this now if you want. And I'm going to go on to practice problem 2. Here's practice problem 2. Okay, so again, pause this video. I want you to try this example, add and subtract these rational expressions. All right, hopefully you pause the video. Here is the solutions to that one. All right, so that is it for this video. We just worked through 2 examples, adding and subtracting rational expressions. Again, we went pretty quick. If you feel like it was too fast and I skipped over some stuff, go back, watch 2-2B. That's the second video. I detail it more, okay? So thanks for watching. One more video. I have 2 more examples that are even weirder, out of this world, okay? So watch the last one. Thanks for watching. See ya.